For the CCNA exam, you must know the OSI and TCP IP models, not just as a list to memorize, but as a practical tool for troubleshooting. The exam will test you on which protocols and devices operate at each layer and expect you to use this knowledge to solve networking problems. Let's start with the 7-layer OSI model. From the bottom up, we have physical, data link, network, transport, session, presentation, and application. A very common mnemonic to remember this order is please do not throw sausage pizza away. The physical layer, layer 1, deals with the actual physical transmission of data. Think cables, connectors, and electrical signals. The data link layer, layer 2, handles node-to-node data transfer and manages access to the physical media, using MAC addresses. This is where switches operate. Layer 3 is the network layer, which is all about logical addressing and routing between different networks using IP addresses. This is the domain of routers. Layer 4, the transport layer, provides reliable data transfer between end systems using protocols like TCP and UDP. The top 3 layers, session, presentation, and application, are often grouped together. The session layer manages connections, the presentation layer handles data translation like encryption and formatting, and the application layer is the interface for user applications. Now, how does this relate to the more practical TCP/IP model? The TCP/IP model simplifies this into 4 layers. The OSI's physical and data link layers are combined into the network access layer. The OSI network layer maps directly to the internet layer. The OSI transport layer maps directly to the transport layer. And finally, the OSI session, presentation, and application layers are all collapsed into a single application layer. The CCNA exam expects you to know this mapping and understand that the TCP/IP model is the one actually implemented in real-world networks. A critical process you'll be tested on is encapsulation and decapsulation. As data moves down from the application layer to the physical layer on the sending device, each layer adds its own header, a process called encapsulation. This creates specific protocol data units, or PDUs. At the transport layer, we have segments. At the network layer, segments are encapsulated into packets. At the data link layer, packets are encapsulated into frames. On the receiving end, the reverse process, decapsulation, occurs. Each layer strips off its corresponding header until the original data is delivered to the application. A common exam trap is to present a scenario where a device is operating at the wrong layer. For example, describing a layer 2 switch making a layer 3 routing decision. You must be able to identify that this is incorrect. This is why the models are your most important troubleshooting tool. If you can ping a destination IP address but can't load a website, you've proven that layers 1, 2, and 3 are working correctly. The problem must be higher up, likely at the transport layer with a blocked port or an issue at the application layer. The CCNA will give you show command outputs and expect you to determine the problem layer. For example, an interface status of up but protocol down often points to a layer 2 issue like an encapsulation mismatch, not a bad cable, which would be a layer 1 problem. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.